Hello and welcome to the last session of the day at the J Champions Conference 2022. My name is Rustam. I will be a host for this session. And today with me, I have the great pleasure of having Mary talking about benefits of MQTT for an IoT and what lays beyond as well. I will let you introduce yourself, introduce your topic, Mary. It's a great pleasure to have you here, fellow Java champion. And just one thing to the audience, please do write your questions in the chat. Add your comments, add your questions. I will be back to the stream later on at the end of this talk and asking those questions to Mary. So over to you, Mary.
Hello. Yeah, thank you so much, Rustam. And thank you, everybody, for coming to the last session of the day. I'm really excited and really appreciate you being here. And I know, too, for me, I was doing more about, talks on reactive Java and all those things. So now is a change for me. This is a new role for me at a new company. So I'll be talking about MQTT. So let me kind of get myself situated because of all of these new things that I'm kind of handling. So let me kind of make sure I am good. And okay, here we go. So first of all, let me kind of introduce myself, but I think I'm still looking a little bit too big. So I kind of want to do it so that I don't block the view. So here we go. Yeah. All right. So thanks again for coming to this talk on benefits of MQTT, which is a protocol for specifically catered for IoT types of applications on the messaging level. And I will, well, the thing is too, as I'm talking more too, and you can find out too, the use is not restricted to only like IoT stuff, but of course, the company itself where I'm working with is HiveMQ. So let me then first introduce myself. So I'm senior developer advocate at HiveMQ. Before this, actually, I was with IBM for about little over 3 years with the Java advocacy team. And I'm based out of Chicago. I'm a Java champion, recently nominated and confirmed. So really honored to be here. And I'm also the president and executive board member of the Chicago Java Users Group. And I also am co-organizers for several IBM-sponsored meetup groups too. And I'm still kind of involved with them, but right now it's hard with the COVID situation. But otherwise, I'm still involved. And then I have extensive experience as a developer for like 25 years or so, and in product and also application design, development, integration, deployment experience. And I specialize mostly in reactive and Java, open source and cloud-enabled distributed systems. So, and here are the ways as to how you can get in touch with me. You can follow me on Twitter or LinkedIn. Or I'm also having a live coding stream on Twitch, and I also have my Discord server. So I'll share with you too towards the end, but that's kind of a nutshell about myself. Okay. So let's kind of then turn to the agenda for today. Again, I first want to talk about the IoT stack. So that stands for Internet of Things, but just for those who are maybe completely brand new to this, which I don't think so. So, and then I then want to introduce to you MQTT, the protocol, some brief history about it. And MQTT as an open standard from the OASIS governing board and community-driven protocol. And I want to bring up some MQTT 3.1.1 features. Those are kind of still widely used. And then there's also 3 years ago when MQTT 5.0 got introduced, there's also some new features that are more catered for a cloud-native type of environment. And then I'll talk a bit about 2 use cases for MQTT and some alternative protocols, for IoT, other than MQTT. And then really then highlighting why MQTT will be like beneficial as a protocol, its strengths, for doing IoT. And then I hope to also get to some demo, and depending on the time that's left too. Okay, then first of all, let's kind of talk a bit about the IoT stack, right? I'm finding, right, for myself, I'm like new to IoT. So when I first started too, I was kind of more thinking, okay, IoT are small devices connected to the internet, and you try to get all of these devices to talk to each other or exchange data. So that's essentially the crux of it. However, too, I'm also realizing that there are people talking about, oh, there's AI, there's machine learning, all of these other things that can make use of IoT. So let's take a look, right? So over here, when we talk about IoT stacks, the devices, right? That's kind of like the kind of it kind of saying that not like using the OSI networking layer, but let's say of things, right? Things are actually the devices. That can be like smart devices, sensors, actuators, and embedded type of devices, all kinds. You can think of your refrigerator, your dishwasher, right? Your car engine, anything. Is essentially anything that can be connected to the internet, to the networking. Somehow they connect it. So then you need to be able to exchange data, because in order to make things, smart, they need to be able to talk to one another. And that's the kind of key of it. So then we kind of, if you look into this stack, right? Now, I'm not being very fine-grained, so please kind of, forgive me, because I'm kind of just mixing up all of these communication protocols from the OSI kind of, layer, and say I'm meshing up all of the communication on transport layer, the application layer, the network and session. So here we have a jumble of different kind of protocols that I'm highlighting in here that's relevant for IoT, or kind of becoming more important for doing IoT. So of course, because I work with MQTT now, I kind of highlighted its first thing. You use MQTT for connection. But there are also other protocols like CoAP, if you haven't heard of it, and I'll touch a little bit on it towards the end of this session. CoAP is basically constrained, well, like I said, for application protocol. So it's a bit different, but it's catered also for IoT. Then there's also Amqp. I'm sure you've heard of it, the asynchronous messaging queuing protocol. DDS, like data distribution services, and then XMPP. XMPP, actually, as you know, that Google Messaging is also using that for I guess, for the Jabber messaging. So anyway, there are tons of things out there, but these are kind of highlighting these. And then there's some industrial ones too, by the way, that I would also bring up too. Then otherwise too, I'm also kind of talking about, okay, on the IP protocol, right? There were IPv4, IPv6, and then there's also this 6-low 6-low-PAN, I guess, I hope I say it correctly, but that's really for IPv6 for low-powered wireless type of devices, Bluetooth, GSM, Modbus, BACnet, all of these things. So, okay, so that's that communication protocol. And then core platform, right? Then we're talking about IoT messaging middleware. Then that's where actually the company I work for now, that messaging, it kind of fits in that category of IoT messaging middleware, which is like so important in powering all of these message movements, right, among different devices. So it's kind of a core type of technology, infrastructural type. And then there are also other things like core platform. You can have protocol, gateway, data aggregation, all these other things. And then, of course, then we get into more of, I think a lot of folks are more talking about IoT. They are talking about the actual usages of it. You're trying to gather reports, data for generating reports that are like, IoT kind of on that stack. Events, machine learning, stream processing, all of these things, cognitive platforms such as interactions type like spoken, gestures, all of these things. You're collecting all of these data from different like devices and all of these, voice recognition, for example. And then we get into top layers, more like really solutioning now. And in terms of IoT, this stack, you can have like largely speaking, right, broadly speaking, and today's world will be like 3 categories. They're consumer, or the enterprise, or the industrial side of IoT. Now, in consumer, it's not hard to kind of already figure out at home, right? We can have dishwasher, we can have refrigerator, all of these things, and your light switch and small like your alarm system, things like that, right? Can be making use of IoT messaging too. Lifestyle, your wearables, right? Mobility, entertainment, all of these things. And then on the enterprise level, business operations, you have ERP systems that you can leverage on IoT. Marketing, sales, business operations, you name it, is there. And then the one area which actually touches on is like industrial side of things, industrial things such as manufacturing, connected cars in automotive industry, logistics, construction, all of these too also involve IoT. So essentially it's dealing with machine to machine kind of communication. Okay, so now get into the crux of things. Now, what is MQTT, right? What is this protocol all about? It is actually a standard binary publish subscribe messaging protocol designed for fast and reliable data transport between devices, especially under very constrained conditions. So that's the key, right? The operating environment will be very limited. You can have very high latency network kind of situation. You can have networks that are dropped and all of these things. So that's where the strength is. MQTT is it has the built-in guaranteed delivery mechanism. That's actually very important to guarantee your messages don't get lost like that. And then, of course, it is very fast too, right? And then constraints is like unreliable. I already talked about the unreliable network connectivity, limited bandwidth, and like your batteries maybe is very, kind of limited too in your devices and all that. So it's very low power consumption. And it's built on top of TCP/IP. It's really ideal for Internet of Things. So there's just a small picture in here to kind of illustrate a pops up kind of scenario. If you think of your cars, you're driving a car, you have your speed, you have your meter. So this pops up model is basically leverage on your MQTT broker. So it's basically you're not letting your device talking to device directly. You're always going through this broker, this middleman, kind of middle person, right? It's do it right. So and say your speed, you have your speed, you need to publish the speed, then all of these data will kind of be connected, sent to your broker. And then from the broker, because these are topics, right? And topics are then being subscribed to by the subscriber. It can be a mobile devices or mobile device, or like some backend servers or some, whatever, you name it, right? And tablet or whatever, right? So whenever data comes in, then the data will then be sent to whoever is subscribing to it. So this kind of a pops up model that leverages on the broker. So, and basically because of this model, it's actually encourages a lot of, many, subscriptions, and there's essentially no limit to, the number of subscriptions, and also like how much data you can actually be published through every minute too. That's basically theoretically can be a very large number too. Okay, so now then, let's take a little bit look too into the brief history of MQTT. So MQTT, it stands for Message Queue Telemetry Transport. Now, the thing is too, MQ, it actually is borrowed from the IBM terminology MQ series, right? So that comes from IBM. However, in today's world, it doesn't have that, have any association with the original MQ anymore. And let's take a look. So it was invented in 1999 by Andy Stanford Clark at IBM and Arlen Nipper at what was then Arcom, which is now Cirrus Link. So at the time too, the two had to do a project of dealing with oil kind of flowing through the pipelines via satellite. So they want to be able to do some kind of measurement. But at that operating environment too, as you can see, it's very limited, right? And there's also like the battery is also very limited too. The bandwidth also is not kind of like big enough. So they both decided, well, we need a better protocol. And that's what it was. And they kind of designed this MQTT for that particular purpose, right? So the thing is too, is that with this limited operating environment, that principle gets carried into today's, right? Basically the IoT, when IoT came out, somebody kind of spotted it, right? There's a potential in here we can leverage on MQTT to further it, to kind of make it adjust to today's world, today's IoT type of application scenario. So again, this is actually also a diagram that can kind of quickly show you. 1999, MQTT got invented for oil pipeline and monitoring. And 2010, then MQTT 3.1 is opened as a royalty-free protocol. And then 2012 too, there's the first, essentially the first major, I suppose, the implementation of this protocol is the Mosquito 1.0 got released. And now that's part of the Eclipse Foundation. And then 2013, HiveMQ is the company I'm working for, is basically got released 1.3, and that's actually implementing the MQTT protocol. And then 2013, that's when the OASIS technical committee was formed too. And then basically 2014 has got some improvement to it, and that got released. And that's essentially the still very popular today is the 3.1.1 version. And then 2018 was when MQTT 5 officially got released. And also then Hive MQ4 then has the MQTT 5 support in since 2018. So that's a quick kind of nutshell. And the MQTT, again, the technical committee, it's all governed by OASIS, this open standard kind of organization. And as you can see, these are again, some background information is these are the companies that are involved, that are kind of more like the obligatory member, have obligatory membership in this committee too. So as you can see, I work for HiveMQ, so the HiveMQ is also a major contributor to this protocol. So now getting a bit more into it is that about MQTT, and if I give you an overview of it, right, quickly, giving you, if I have to tell you, why do you want to use it for IoT? Basically, it's an messaging protocol, and it has 3 quality of service levels. So these kind of basically are important in terms of guaranteeing your delivery of your messages too. And I'll get a bit more into that detail. And then there's also the retained messages type of functionality in here. And also the stateful and persistent sessions too. And that's absolutely very important in any kind of event-driven, like asynchronous type of operating environment. As we know, when we do publish and subscribe, right, messages get published, and there's got to be a way of kind of persisting them. What if, the network gets dropped, something doesn't kind of stay, then you have to have some way of kind of persisting the data. And that's where the broker is so important in terms of helping and keeping the stateful data in a IoT type of context in this case. And essentially too, it is a binary protocol too, and so it's got minimal overhead. It's essentially really lightning fast too type of protocol. So now then let me get into the bit of the basic features of MQTT 3.1.1. Over here too, like a message will get sent. So as you can see too, over here, basically a device, right? You can have a connect. Every time, right, we go through the broker. So you basically have a connect that you kind of make, kind of talk to the broker. You make a connection, as you can see in the MQTT packet. It contains the client ID. And then there's also an indicator of whether it's a clean session, and your username and password. And also this it's called last will topic. So last will is kind of, oh, I'm sorry. Okay, here I'm back. Sorry, kind of a little quick thing. Okay, so I'm still here. And so the last will topic. And so essentially too, with any kind of this kind of pops up system is that it relies on the topic, because the topic is what kind of labels what this message is for, and also for the subscribers to know who they can kind of the kind of topic that they can that they're interested in, right? You have to have some way of kind of letting them know, okay, I'm on this topic and you can subscribe if you want. So over here too, and then I was talking about last will topic, and essentially too, last will topic is kind of an interesting concept, because it means that if like something, your connection is dropped, and basically it's on the client side, on the MQTT client, you can basically indicate that, okay, this message was sent only if I die, kind of like that. You can kind of think of it like that. So in other words, the broker will have the responsibility if the client dies before it gets delivered. So then basically this will indicate what topic it is. And then also too, over here, there's also the QoS level, and this is quality of service. In this case is 2. It just means that the message has to be exactly delivered only once, like that. And then you can also, then this packet carries with it the message. In this case, whatever you want, it's just a string. You kind of indicate the message it has. And then there's also a retain. Do you actually want to retain these messages, right? And even after it has been delivered, you can also indicate that too. In this case, it's false. And then there's also a keep alive. It's basically saying that you want to make sure that the messages keep alive for 60 seconds in this case. Now, in this case is that once you make a connect to the broker, and the broker will come back then with a essentially it's an acknowledgement. So it's a connect packet to kind of go back to the MQTT client. And this actually contains the session present. Is it present? And then there's a return code. And that's what the connection ACK kind of gets sent back to your client from the broker. Just now too, I mentioned about the will. So the will is basically the client will define this will. It's basically the last will kind of message, right? Message too. So broker will send this message if the client dies. It is actually a push message in this case. So let's say if during all your message exchange and the client somehow kind of is lost, and in that case then the broker will then send this message on behalf of the dead client. So it is a push message too. So it gets pushed to all of those who have subscribed to this particular topic too. So it's very important to kind of it's actually useful to implement like on-off type of mechanism in a very safe way. So it's again, it only gets delivered from the broker to those clients who have subscribed to this particular topic. So over here too, as you can see too, it's kind of like the same kind of example in here. You have client ID and then the clean session, all of these, but you can see too, there's last will topic. Which topic is it? And then there's a QoS level. Excuse me, and then what your message you want to be conveying to your, the subscriber, and then to keep alive. So, okay, so now then I kind of get a bit, kind of a little kind of into the original kind of talk, right, about this pub/sub type of mechanism in here, which I already kind of talked about, but let's kind of just illustrate using this particular example. So in this particular case, like a good example is you can have like an IoT sensor that's actually collecting temperature. And then you basically, every time if there's a change in the temperature, you can actually be publishing this too, depending on how you code it up. But you can publish this temperature measurement then to the broker. So broker, think of it like a middleman, kind of like that. You basically publisher, your publisher client never talks directly to your subscriber client. So it's always through the broker. And then basically whoever is interested in it will have to subscribe to this topic. So then when the messages arrive, then it will get published to whoever has subscribed to it. So in this case, a laptop has subscribed to it, and a mobile device, they will all get pushed, or actually I should say they will all be receiving, right, these messages when they are available, or in this particular case will be the temperature that gets registered and get published onto the broker. So this is kind of a quick way of describing the pub/sub type of protocol. And over here too, if you want to take a look into the pub/sub packets too. So over here, if you look into the publish too, there's a packet ID number, and then and that identifies to that particular packet, and it's always 0 for QoS 0 because, and I'll get into a bit more of detail too. And then there's also the topic name that you need to be specifying. Where is this publish topic? What is this topic? And then the QoS level in this case is 1. So 1 indicates that you only want to have it deliver actually is 0 or 0 or 1 or more times to it. Or actually, I should say 1 or more times. Yeah, you can have that level of delivery. And then the retain flag in this case is false. And then the payload will be just a temperature measurement in this case. And then there's a dupe flag, we have a false in this case. And then the subscriber, on the subscriber side, right, then the packet will then contain, when it's kind of receiving it, then it will have the packet ID of a different packet ID. And then it's basically indicate QoS is 1. And then for the list of topics that this particular client has, right? And then in this case, there's topic 1 and then topic 2. It has actually a list of, on the subscriber packet too. Subscriber side, it will have packets containing like multiple QoS level for different topics as well in this particular case. So. Okay, so now then we also take a look too into the retain message too. So retain message is basically, it's kind of dealing with last known good value. So it's basically the last known value that has been delivered or published is the good value, and it will be stored on the broker side. And then the client decides if a message is retained or not. So it's all like the client control, whether you want to retain or not. And basically what is it for? Is basically for any future client may get this retained message in when subscribing to the topic. So it's basically some client decide that, okay, there's important that maybe some sort of like announcement, things like that subsequent clients would need to know. Then you would want to set this particular retain flag in your message to kind of indicate so then the broker will know if it's kind of got delivered this message, it will be retained, and then any future subscriber to this same topic will also be receiving this message too. So that's retained message. Now, then let's get a bit more into the quality of services. So this is actually very important for like asynchronous type of delivery, because again, right, if you're doing like asynchronous stuff, and how can you guarantee, right, you can actually send some messages and nobody tracks it and like that. So it's basically through these mechanisms, the quality of services that that's actually built in, and it's actually it's built in into the MQTT protocol that guarantees the delivery of your service. And the first of all, there are essentially like 3 levels. So Qos Zero. So Qos Zero is basically at most once delivery, but think of it more like a fire and forget type of delivery. So that's why too, if you kind of recall earlier in the packet too, is that the packet ID is 0 because it really doesn't matter. I just publish, I'm responsible for publishing, and I fire it. And if once I fire it, I forget about it. I don't care actually if it's actually, from my side to actually receive it or not. Now, that kind of scenario, I would think would be things that, for example, you have maybe you are collecting certain data that may not be as like, say, like critical, so to speak, and you just want to be maybe collecting, say, some temperature information that you may not actually need to retain it for whatever reason too. Then in that case too, you can have a publisher that simply just publish it and then it's done. And then basically you don't worry so much about the fact that, even if it's kind of like not, you don't, I should put it that way. You don't necessarily worry about letting the publisher know that you have received it, kind of like that. So it's more like, fire and forget. The publisher doesn't worry as much. And then the next level is basically quality of service level 1. So that's actually the at least like once delivery. So in this particular case, it's at least once, but you can also have like multiple kind of deliveries as well, to more than once. That will be acceptable on the QoS 1. And as you can see too, there's also then another level, which is QoS 2. And this level 2 is interesting. It's basically exactly once. But as you can see over here, this illustration too is that you can have like multiple kind of trips too, because of the fact that you want to make sure only one and no more and no less. You actually require more kind of acknowledgement between the broker and also your client, your particular clients too. So in general too, QoS 2 is also a bit more, takes more time. It's a little bit less performance scenario, because you have to do this extra kind of checking. So let's kind of like take a look a little more into each one of them. So quality of service 1, of services 1. So as you can see over here, my client, right, we publish to the broker. You publish it, it's level 0. You fire and forget. You don't really kind of like worry about getting back anything. You just fire it and that's it. You assume, or you kind of like completely trust your broker of taking care of things for you and sending it to whoever is subscribed to it. So over here in the packet too, then you have topic name and the QoS indicator of 0. There's a retain flag of false. And payload is just a temperature measurement to it, and then a dupe flag like that. So this one would be like a really quick, in terms of the whole kind of operation in this case, because there's really no need to kind of hear back any kind of acknowledgement in this case. And then quality of services 1 in this case will be like how many? Like we're saying that at least once. Yeah, I sometimes kind of still get confused. I always thought, okay, 1 must be like more than once, but or at least exactly 1. But no, it's actually level 1 is at least once, and that's what it is. So okay, so if you take a look into the publish, right, and over here your packet ID is indicated by 4314 in this case, and the topic name. Quality of service and retain flag of these, like here, standard packet. And basically you send it to the broker. So the broker will have to kind of send back to you, the client, a pub ack acknowledgement too. So it basically contains the packet ID 4319. So then okay, my broker already received this message. So that's quality of service. But it's kind of slightly, less performant as quality of service 1. But okay, so now then let's take a look into quality of services 2. In this case too, is that we want exactly once. So first, we take a look into the packet, right? Publish. We're packet ID 4314, and we're publishing the same way, but the QoS actually is interesting. Why is this QoS 1? It actually should be 2. Anyway, okay. Anyway, so we publish, and then we have QoS 2. So 2, again, is about exactly once. So in this case, too, the broker will then send back a pub rec. It's a receive. I receive it. So, and in this case, back to the MQTT client, and then basically too, then my client too, in this case me, right? I call myself my MQTT client. I will actually be essentially too. This is called pubrel, and pubrel is basically go back to the broker and says, okay, I got it, I got your acknowledgement, like that, and then basically then the broker will then send back and say comp is like complete, my publish has completed because I make sure that you hear back from me. So now I let you know, kind of like that. So it's a bit, again, because it needs this extra step, even though, okay, is very small, but still it adds a bit to the performance side of things. And that's QoS 2. Yeah, that's right. Okay, now, so that was kind of in a nutshell of MQTT 3.1.1 or kind of 3.x kind of features. And there are more features too. I'm just kind of highlighting some of these key features in 3.1.1, which actually too is also applicable, and it's all encompassing by MQTT 5. So in other words, MQTT 5 built on top of MQTT 3, it has all the features of MQTT 3.1.1. But before we get to the MQTT 5, let's take a look, right? Even for me too, when I first learned it, I'm like, MQTT 3 and where is 4, So it's just a kind of trivial pursuit, if you're curious, right? So giving you some hints is basically, if you look at the connect message packet detail for MQTT 3.1.1, there's actually a field called version. So the version in MQTT 3.1, the version is 3. And then whoever was like designing it, 3.1.1, the connect message has version number 4. So it's already taken 4. And so now, as you can see, the next one naturally is version 5 for, the connect message for MQTT 5. So in this case too, as basically the designer, the community decided, okay, we're just kind of like name it MQTT 5 instead of kind of like calling it 4 in this case. So that's just a little bit of trivial, as it doesn't really affect how things work. Yeah. So yeah. Okay. I see some question, Jasper. Let me try to answer you after too. Okay. And that way I make sure I kind of have time. So, okay. So now then let me move a bit too into MQTT 5 now. And again, MQTT 5, I won't have time to kind of get into a lot of details as such, but just want to give you an idea and just some key features. So MQTT 5 is successor of MQTT 3.1.1, and it's non-backward compatible too. That's an interesting thing. Now, the one note to kind of notice is that in HiveMQ case, right? Now, again, I'm not trying to be marketing, but I'm also trying to understand all of these things. So MQTT, or actually HiveMQ, the strength is broker. So there's MQTT protocol that it implements. So the broker actually is very nice. You can actually run both MQTT 3.1.1 and then MQTT 5.0 messages too. So that's the kind of nice thing. It can handle both at the same time. So that's something I wanted to kind of point out. And okay, so MQTT 5 is a relatively newer, version, and it was released in January of 2018, and its official release was in 2019. So it's a relatively newer version of protocol, many new features, and also it clarifies the 3.1.1 specification. To me too, when I read about it, I think it's more like catered more for the cloud native kind of application too, and it's kind of built, kind of ready for that, and it's kind of what it's aimed at. So again, these are the goals, right? So goals is enhancements for scalability and large scale systems, and also improved error reporting. So a lot more support for this scalability aspect, which is kind of really timely too for the cloud native day and age that we are living in, right? In large scale type of systems. Error reporting, the observability has improved and everything. And it formalized these common patterns, including like capability discovery and request response. It's going to be supporting also the request response kind of way of doing things too. And there's also like extensibility mechanisms, because you can actually define user level properties in your meta kind of header information too. So that's kind of give a lot more flexibility to how you can program it and leverage on that aspect. And there's also obviously too, like performance improvements and support for like smaller clients too. So that's in a nutshell, kind of what it is. But some like key new features I like to point out, for example, like session and message expiry. So that's an optional. Now, just kind of let you know too, a lot of the 5.0 features are what they call optional features. And then not all vendors have implemented those too. But I like to point out, and some of the things is that HiveMQ has already implemented. In fact, one of the features that's actually before MQTT 5 got published too, and I'll discuss shortly. But first, let's look at the session and message expiry. So it's optional part of the connect message, and it's basically it lets you specify the expiry interval in seconds too. And broker will expire the session after the given interval as soon as the client disconnects too. And again, is an optional feature for the publish side of things, and it applies to online and also queued messages too. And then user properties, as I mentioned about, that's more for the metadata like headers too. And it can be part of, most of the MQTT packets, right? Like the connection that we look at, the con, the pub, and the sub too. So it kind of gives more flexibility if you have like specific, like user customized level of properties you can kind of leverage on these features. And they're UTF-8 encoded strings. And also an unlimited number of user properties can be added to it. So now, this is the one that I was going to talk about, is the shared subscription. It's basically, this one is interesting. And it's, again, from HiveMQ point of view, is that they actually implemented this before even MQTT 5 came into being too. And then basically too, with these features, it became like part of the feature for MQTT 5. And the usefulness of such is really helping you to like scale out your backend subscribers too. A lot more on the client side, load balancing, and different. You can have multiple clients essentially sharing the same subscription too, and it's supported by MQT. I already mentioned, supported by HiveMQ for MQTT 3, the 3.1 and 3.1.1 kind of versions too. So as you can see, it's already been implemented before MQTT 5. And basically too, it helps with upscaling of your clients and downscaling at runtime. It's possible. So it's really like cloud native ready. This feature is really good for like, in let's say you using like multiple cluster type of environment too. And this is, again, an optional feature, and it's not supported by all vendors too. But I think if you're kind of getting into the cloud native type of implementation and or kind of deployment, this would be a features that you can certainly look into as well. Okay, so this is just a pictorial description of this shared subscription kind of scenario. You basically can have the topic, right, being all shared by multiple clients to kind of share one subscription is shared by multiple clients like this. So these are just like a picture kind of describing to you, because otherwise too, the 3.1, if you just use the non-shared subscription, it's always like one topic and one subscription kind of a scenario. Okay, and then there's also at the MQTT 5, there's also the request response pattern too. But the thing is, the thing to note is that it's not the same, right, as the normal way we thinking of HTTP synchronous client server based. So basically too, these are still request response, but they are topics based too. And it's basically you can have one or no subscriber in MQTT. And basically too, the client must subscribe to a response topic prior to sending data to. So it's kind of like slightly different kind of concept, and not the same as what we think of it like a typical request response kind of paradigm or pattern too. So and here too, there's one note about correlation data header for correlation of the request and its response. So it's a bit, I think in this case too, is interesting. It is kind of making use of the request response type of kind of paradigm in terms of you being able to identify each other. But yet it is not like, what you call it, tightly coupled too in this case, but it has this thing called like correlation data header too for that. So okay. And this is actually a pictorial description, right, of this kind of interesting pattern. You can still publish your messages to topics, and basically you have your broker, and then you have your application to over here. Your messages get sent to whoever is subscribed to it, and then basically you can kind of return the message back, through your broker back to your publisher too in that. So this is kind of an interesting feature. It's actually even new for me. So you can take a look into it if that may suit what you're trying to do too. So. Okay, so now then, after a bit of an introduction of these two versions of the MQTT protocol, so let's take a look then into some like alternative protocols to MQTT. First and foremost, is the HTTP. Everybody is still kind of using HTTP, and I'm aware too of folks still using HTTP for doing kind of connecting devices and all that. And sure, you can do that. But the thing is that we have to understand for HTTP, right? It's a heavier and is completely like request response, a heavier type of protocol, and you can do things. It's not like messaging, right? You need to kind of go through using the resource get or doing all your get what is it like get and then delete and then update and post and all of these things. So it's definitely a lot heavier. So what if you want to scale it, right? You need to have a lot of clients and everything, and then you have to have like so many connections, and obviously it's just not becoming realistic if you want to try to scale it, unlike something like a PubSub type of model. So with HTTP, you can maybe, if you know that your number of clients is small, yes, you can still use it, but it's definitely not ideal if you want to try to scale it to some kind of scenario when you have many connections that are needed. Okay, and then there's also this second one is the constrained application protocol. CoAP is called. This one is interesting. It's actually also an asynchronous type of protocol, but it makes use of UDP. So UDP, as we know too, is also a TCP protocol, but the UDP itself, user datagram protocol, it doesn't have as much of a message guaranteeing in there too, but it is very fast. You can no doubt about it. It's actually quite fast, in fact. And it's also kind of like designed for like constrained type of environment. So it all depends, right? And you can still use CoAP. For example, you have Raspberry Pi and you need to be connecting, right? Doing all these connection and everything. You can still use CoAP protocol to do it, right? And it's really, really fast. So I think the thing is that with CoAP, probably the best case scenario is maybe some utility type of things, maybe your dishwasher or something, right? Something like that. Then okay, you need to just send you a message, something like that, right? I'm just kind of like imagining some of the case scenario too. So. Okay, so that's CoAP, and then there's also then the advanced messaging queuing protocol too. As we know, that comes out of the it's actually advanced AMQP came out of originally from JP Morgan, the banking industry too. So they were kind of more for the finance type of kind of a area of application too. And right now, AMQP is also part of the OASIS kind of governing body as well. So it's becoming an open standard, through the time, pass through time. So like that, that actually is a possibility, but it's probably also like not as kind of catered ideally for more smaller devices like IoT type of devices, such as like for MQTT case too. So, okay, now then there's also another one. If you are kind of working in more of a manufacturing factory type of places, right, where you're dealing with process control and operational stuff like that for a factory floor, then you might have heard of this OPC UA, which stands for Object Linking Embedding for Process Control, and is a unified architecture. So a long word for it. Now, over time too, it has improved now to be more efficient and everything. But then it makes use of this thing called the SCADA host too. And also too, it's interesting. It's actually it's a bit more kind of making use of SOAP type of messaging, the SOA type of architecture too. Now, the thing is too, is that it came out before, so it was more designed for more really the manufacturing factory floor type of kind of scenario. So it may not be as ideal for certain type of scenario too. And it has improved over time, but still, I think the overall kind of usages may not be as ideal then for if you're dealing with small like IoT type of devices. That's what it is. So that's that. And then there's also this thing called data distribution service. So this data distribution service is more like for, as the name implies, it actually handles more of the data itself too, and how it distributes. And it's actually quite efficient too. And maybe if you are kind of like working with databases and things like that, more with that may be an option for you to also look into that. And yeah, so, and also too, it also has a branch of it that it can work with the OPC UA kind of, yeah, protocol too. So, okay. And then the last one too here that I'm kind of like specifying. Now, again, there could be other protocols, but again, these are the ones that I'm aware of that are a bit more kind of used in the current IoT kind of industry space too. And then there's also XMPP. XMPP is Extensible Messaging and Presence Protocol, which actually is more, I think, catered more for instant messaging type of scenario. So such as, I think, the Google Messaging too, they are making use of XMPP. So not to say you can't use it for IoT scenario, but it's also as such too, XM is actually indicates it's an XML-based type of protocol too. So it's maybe kind of a bit of anytime we know when we work with XML data is a bit kind of a heavier kind of implication. But however, it is very actually good for doing like instant messaging type of scenario. So, okay. So after this, let's then take a look. I'm kind of talking too long now. So let me kind of go to the next slide. So now then, look, I like to just kind of talk a bit too about use cases for MQTT. So as such, MQTT is basically, it's not restricted for only IoT kind of scenario, but I think IoT is really like everywhere now. So it is becoming kind of like de facto standard too for IoT. It's really designed to be very, very extremely scalable. So lightweight and easy and everything. And also too, would like to kind of mention too, which I didn't talk about, is basically MQTT is very light. I didn't talk about specific, right? The headers too is actually only 2 bytes. So it's very small, very, very small. Now, there's also variable headers, and that can be up to only 12 bytes. So that's also kind of small, and it's not needed if you don't need it to. So that type of stuff. So it is actually very, very efficient in that sense, right? So, okay. And then, of course, too, there's this industrial IoT, IIoT in there. So it's more for industrial purpose. And then there's also this current kind of a state of the industry, this industry 4.0 kind of application scenario, in which in a nutshell, industry 4.0 is like dealing with interoperability between like different types of technology that you can kind of all be grouped together and create solutions for like bigger problems, right? Like in the industry, in like doing like factories, manufacturing, logistics, construction, you name it, like that. So those are kind of like the things, the use cases that MQTT can be used for as a very solid like IoT messaging kind of layer in that case. And then there's also industry verticals, right? Such as like here, like automotive, like connected cars. You have like small devices that are sending maybe data to your broker to kind of adjust, certain kind of things. You can always be thinking of using MQTT. Logistics, right? You can have shipping, right? Your maybe trucks, they're delivering goods and things like that. They have their handheld devices. They need to be communicating maybe with office or with something to get data, all these kind of things, and they need to have some real-time kind of communication. You cannot afford to lose time, right? If you have UPS delivery man wanting to deliver something real fast and that type of stuff. So, okay, so logistics, manufacturing, and energy industry too. For example, oil and gas industry too. There's still kind of can be making use of MQTT too. And then on the consumer side, you can have smart homes, right? And lifestyle type of thing, wearables, all of these things. And I like to also point out, right, MQTT, for example, I actually have my dishwasher recently, got a new dishwasher, and it's interesting, I installed the app. So every time it does its job, it would kind of call me when it's done to, it would beep, things like that. And actually, because I didn't use my dishwasher for a while, then it beeps me and said, hey, it's time to do like maintenance work, things like that, right? So you can kind of like think of all of these like interesting scenario that you can use, make use of MQTT to do all of your messaging needs. So. Okay, so in summary, too, basically, simplicity, right, of this MQTT protocol, pub/sub, asynchronous processing, loosely coupled, and basically now with MQTT 5, which I actually didn't put it here, is basically that is all kind of like ready for cloud deployment, cloud native ready, lightweight, and is ideal to operate in a constrained environment. Environment that has networking with high latency, right? And you want things to still go fast in places where there are limited battery and other resources, and it's essentially ideal for IoT use cases. So. Okay, so this one I actually didn't mention. Well, actually, I maybe a little bit out of out of sequence. But the thing is, too, wanting to point out maybe another thing is with this messaging too. It actually the stateful side. It also supports the stateful sessions too. So in this case too, you can have persistent sessions, and broker can store messages when offline. So essentially too, all of these features I already went through, right? All these are the broker is, that's why it's very crucial. It handles all of these things, maintaining state for you. So that's kind of really nice in that case. So. And also too, just a note to kind of point out is that we want to try to like achieve like IoT scale. Right now too, it's basically you'll be. When I first look at these statistics, right, it's basically too probably still needs to be tested out. But the thing is, we believe that we can do like with a really well-designed broker, right? You can do like 2.7 million publishes per minute, and you can do like 100,000 topic subscriptions and X number, X kind of 100,000 of connected devices, and 100,000 of Q publishes too. So these are true like in IoT kind of scale kind of scenario. So. And with that, then I will, I think I still have some time, right, Rustam? So I'm going to just go and quickly show you too some kind of quick thing, right? How do we kind of do things, right? So let me kind of go over here. And here too, I wanted to also invite you to sign up. There's a free tier, HiveMQ Cloud, and forgive me, I'm not I'm not doing like big kind of what you call sales in here, but because there's free tier usage, and that's what I'm trying to encourage of you to kind of give it a try. So if you go to the our site HiveMQ and then MQTT Cloud Broker, I will kind of quickly kind of share and here and you with you. So you can also always kind of sign up to, it doesn't cost you anything. And basically over here, right, free to connect up to 100 devices too. No credit card required. So you can basically click on that. And like I said, I already sent it to you over there. And so over here, well, actually, I had mine kind of earlier done that, and I will have my HiveMQ. But you can sign it up. You can use your Google single sign-on too as well. Okay. I thought I had already kind of signed up. I'm sorry. Okay. Okay, all right. That's fine. Actually, I've already signed up, but I don't know why it's asking me to do it. I think it does require me to say something. So if you want to give it a try. I'm so sorry. I guess it does require me to say something. Okay, I have AWS, for example. Okay. So now I'll just say, okay, I'll just set up my first, and I'm so sorry. I thought I already signed up. I'm not sure. I guess I didn't have time beforehand to try this out. So, okay, let me kind of say, okay, I have Mary G, and then I'll just say something like, wait, let me kind of do something so I can remember it too. Okay. Oh, I guess it doesn't like it. So it does want me to have some kind of a serious password. So let me kind of set something up so then I remember. Okay, so as you can see too, this is pretty neat, right? So once you sign up, you can have basically set up credentials, which I did already. Then now you can actually connect your first MQTT client too. So in our case, what we can do is maybe use this command line tool. Oh, actually, you know what? Let's take a look at the WebSocket tool too. That might be like in terms of like being like a little bit faster too. You can kind of give that a try. I guess I'll make it a. Let me see if I can actually improve the it looks like is it big enough to look in here? Let me try to. For some reason, I cannot make this a little bit bigger, so I hope it's okay. So okay, so now to be able, it's talk about head to this WebSocket client, and basically you can access here. But let me kind of open in a new link. So over here, okay. And then basically, let's see. Okay, so to be able to interact, right, with this cloud instance via this WebSocket client, you input the host name. So in my particular case, my cluster into the host field of the WebSocket client, right? And so so let me do that. And again, this is, you can use it too. It's actually, for me, this is just for demo. So even if you use it, it will be okay. So, oh, it's already copied over, so that's good. And in this case too, then I have to enter my password and keep alive all of these things. And then last will topic, I'll just say, okay, maybe I'll just say last will, yeah, something. And then the QoS is 0, something. The message will be, this is J champion, champions conf, something. Okay, now I can then do a publish. Actually, what is it? Actually, I need to connect first, of course, I forgot. So you just do a connect. So now this is connected. And basically too, oh, the topic is already there. And then I can just say publish, let's say test 1. And we can just do publish, wait, and then add your topic subscription and then subscribe, right? And so now I think I should be able to then kind of like something publish. So you can see, then you can immediately kind of see that you try to publish in here and then like that. So yeah, so again, you know, this again, right, because I'm kind of running short in time now, so I would not have as much time to step through everything, but I just wanted to quickly show you this WebSocket client, how easy, how quickly you can kind of kind of give it a test drive using the HiveMQ cloud, which doesn't cost you anything. So please consider signing up and just give it a test run to see how you like it too. And then actually another thing is, I don't mean to be like advertising, but I will actually be doing a webinar too on Wednesday. There, I probably will be doing a bit of in-depth, not too in-depth, but a bit more in-depth of a demonstration as well too. So if you want to come to join me, though, you'll be welcome. You're welcome to join me too. So, oh, I'm sorry. Somebody was saying that a little bigger. I'm sorry. But come to my webinar on Wednesday, and I'll give you the information, and you can join. So. And then with that, because I'm almost time, so I wanted to, at this point, just share with you the resources of Mqtt. If you go to the Mqtt at Oasis, it will give you a lot of information too. And then if you want to get started with Mqtt over here on the left side, it's actually, you can, it has example of, you can write your Mqtt client in any languages. Most popular languages is Java, JavaScript, Python, Go, and PHP, and Dart, and all of these things. So, and then there's also the Mqtt Essentials series that we recommend you to read too. Is a lot of real good materials there. And if you want to evaluate HiveMQ and also try, again, I just shared this link already with you in the link in the chat there. Try out HiveMQ and kind of see for yourself if it is something that you find useful. So, okay, and here, let me go back. And if you have any questions, I welcome you to ask me. Yeah, so, and thank you. Now let me kind of make myself a little bigger now.
Thank you very much for this great talk, Mary. There are a few questions. We have,
Sure.
we'll start them in chronological order. So,
Sure.
yes, but what kind of hardware would be required?
Yeah, sure. So it is very true. You can actually try out, and even I myself too, yes, you can use Arduino. There's also ESP32, that microcontroller that's actually you can plug it in and connect with the Arduino IDE as well. That's something I want to try too. I have to admit I'm fairly new to the company. I'm still trying to order all these things too. So, but yes, you can use Arduino. You can use Raspberry Pi, and I like to point out to Frank Del Porte. He has actually written up on Raspberry Pi how you work with MQTT Broker, and we will both be speaking at FOSDEM in 2 weeks. So if you want to go there, and I will be speaking again about MQTT. Hopefully it will be like even better next time. So yeah, so yes, and you asked the right question, Jasper. Yeah, you can use those. Yeah.
Those tiny computers are really cool. You can actually, it's you use the same software as on Arduino, and then you can just do a lot of things, and really fun to play with Qs.
Really fun. Yeah. I hope to do some more streams to my Twitch stream. I want to know how to set it up so then I can show the board, right, when I'm coding and publishing messages. So yeah, so look for me there. So
quick hi from Maximilian. So that was not the question, but just a hi. That's the question. So now we have a question about encryption, how it works on the client and server, and if it is an out-of-the-box feature.
Yeah, great question, Eduardo. Yes, actually, very good question. I know in terms of, I know we need to pay attention to like security side of things. So we support SSL and TLS, but encryption, I think that's an excellent question. Let me go find out the answer, and then I will. I don't know how to connect with you, but connect with me on my Discord server. I will find the answer out for you. I think you should be able to use encryption too, but I don't have the exact answer for you. But let me go find that out for you. So. Yeah, thanks for asking. Okay.
Sounds great. There was a comment from Jesper again about the headers and that it might be a little bit of payload.
Yeah, that's right. Yeah. HTTP is definitely is heavier too. I think in terms of especially if you compare with something like MQTT to do messaging. So yeah, it can be. Yeah, I believe so. So
I believe. There are no more questions. I mean, if I missed some of the questions, I apologize in advance, and please type them again, copy paste them, give you a few seconds to write the last kind of questions, comments, anything that you might have. And while you're doing that, okay, there is a comment. Encryption. Okay, let's see what it is. Encryption on tiny primitives. Yes, that's correct. That is.
Yeah, I don't think. Yeah,
there is not that much computing power, basically, right? So that's more of a comment. So yeah, that might be an issue. But on the other hand, they can be. I mean, correct me if I'm wrong, but the little I know of that is that they usually would be quite optimized to do some of those things. So that might work after all.
That's true too. But that's a really good question. I should really go find out. Yeah, that's right. Yeah.
Great comments. Thank you. Thank you for your comments and for your questions.
Yeah, and I will also.
Any last questions before we round off? And while you are, and if you're typing, I'll use this time to say yet again, thank you very much to you, Mary, for doing this great talk. Thank you, everyone, for joining us today. It's been really, really great to see so much engagement, discussions, questions, comments, and talks. That's really, really, really nice.
Thank you.
Thank you very much.
Thank you, Rustem, for hosting me, too. Thank you so much.
My pleasure.
Thank you. Yeah. So please connect with me. I wanted to say, you can follow me on Twitter. I also have my Discord over here. I don't know if it's too small for you to scan, but also follow me on Twitter. Please stay in touch. Yeah, I would love to hear more feedback from you too, especially in such an exciting field. So much potential. So yeah. So yeah. Thank you.
Thank you.
Thank you.
Bye-bye, everyone.
Bye. Thank you.